In this video, we will cover how to frame and panelize a floor. For training purposes, we will frame the first level floor and panelize the second level floor. Let's start with the main floor. Go to the first level deck layout, go up to our drawing model pairs, and select first level deck layout. Before we start working with our floor framing, we need to set up our wall references. Currently, the main floor level walls are referenced. If we want to see our lower bearing walls or basement walls, we will need to add a reference drawing for our basement level. We'll go up to Reference Drawings. Select Properties to view which reference drawings are available. Click on Properties. The reference drawing for the first level walls is enabled. This is a reference drawing currently on screen. We'll need to add a reference drawing for our basement walls. I'll hit Cancel. Go back to Reference Drawings. From the menu, select Quick Load Drawing Model Pair to add a new reference drawing. From the Drawing Model Pairs dialog, select Basement Wall Layout. Now you see that we have both our main floor walls and our basement walls visible. We can leave both walls visible, or we can turn off the main floor walls. To turn off the main floor walls, go to Reference Drawings, Properties, and now you see we have two reference drawings, the basement walls and the first walls. Uncheck the first walls and select OK. I'll work with both reference drawings active, so I'll go back to Reference Drawings, Properties, and check the box for first walls. Having both active at the same time will help to ensure that objects are lined up properly. Similar to walls, floors also have framing tools. If you recall from the wall training video, walls have framing tools for setting framing parameters such as framing materials, spacing of framing members, framing details, and various other parameters. To access the framing tools, select a floor. When you select a floor, you'll see a new Plane Structure ribbon menu appear. You can access framing tools from the menu, or you can right-click, and from the context menu, you can also select framing tools. In the Framing Tools dialog, you'll see the type, which is frame, the tool library that it comes from, this is a floor structure, and the framing tool assigned to the floor, a 2x12 wood floor framing tool. We have three tabs: Framing General, Direction and Alignment, and Insulation. Under the General, you can select your on-center spacing. Under Joist Detail, you can select between single or double floor joists. You can make the selection by clicking on the diamond. We'll leave it as is. Under Joist, you can change the material type or grade. The material can also be changed for the side and header members. In the Piece Properties dialog, select Grade to change the grade. Do not change the depth of the framing. That is done under the 3D levels. For direction and alignment, I'll leave it as is. We'll make the changes using the Fields tool. We also have an Insulation tab if you want to add insulation. I'll select Cancel and leave it as is. Just to refresh your memory where the 2x12 floor framing came from, when we first set up this project, we went into 3D levels, and for the first floor and the second floor level, we changed that to a 2x12 floor system. That's where the 2x12 floor framing came from. I'll select Cancel to close out this window. If you plan on providing a sheathing layout or want to see the sheathing panels in the model, the floor layers must be unpacked. If you do not care to see the sheathing panels in the model, then pack the floor layers. Note that the sheathing is not removed. It is hidden and will still be included when generating materials lists. To expand or pack your floor volume, first select your floor volume. Under the Plane Structure menu, go over to the left. Under Volume, you have Expand and Pack. If you set your volume to expand, and we generate our parts, you'll see the floor sheathing included with your framing. If we go to 3D and switch it over to framing, the floor sheathing will be added to your model. I'll go back to 2D. I'll remove the framing. And this time, with my floor area selected, I'll select Pack instead. And now when I go to generate my framing, the floor sheathing is not part of the framing. And if we go to 3D, the floor framing is generated without the floor sheathing. So go back to 2D. And to delete your framing, select your area, and up under framing, go to remove. Now I'll generate the framing one more time with it expanded. Now if you have the sheathing visible, but need to temporarily hide it, you can select one of the pieces of sheathing, Control A to select all, and hit H to hide. It's still there, it's just hidden. To return it, you can right-click, Restore Hidden. There are several ways that you can do this in 3D. Let's go to 3D. Similar to the filter method, you can select a piece of sheathing, Control A, H to hide, or right-click and I'll restore it, or go to the lower left corner and select the model browser. We're working on the first floor, so we'll find the first floor level, select our plane structures, locate the 2x12 floor framing, expand the branch, next select the sheathing branch. Right-click and select Hide. To restore, right-click on the 3D view and select Restore Hidden in the menu. I'm going to go back to my architectural view and hit F2 to go back to 2D. Now I'll go back and remove my framing. One thing to be aware of when working with expanded layers is that you may be selecting the wrong layer. You click on the floor finish layer instead of the floor framing layer or volume. A way to determine if the correct layer was selected is to select a layer. If you pick the floor framing layer or floor volume under the plane structure menu, the fields and edge tools are shown in the edit framing section. If you select a different layer, like a floor finish layer, it will look something like this and have more grip points. This is indicating our selection of the hardwood floor layer that we added earlier in this model. When you look at the framing menu, the fields and edge tool is not visible, indicating that you did not select the floor framing layer. If you select the wrong layer, continue selecting layers until you pick the correct one. Hit Escape to cancel that selection. Before we generate our floor framing, we need to determine the direction of the floor joists and how they will be supported. We'll have the joists run front to back. Over in this area, we'll have them run left to right. For support beams, we'll add a drop beam over the family room. We'll add a flush beam to support the floor joist along this wall. We have 3 columns in the basement that will support that member. To adjust the framing for a floor volume, we'll need to work with the Field tool. To access the Field tool, select your floor area, and under the Plane Structure menu, under Framing, click on Fields. On the screen you will see a origin marker, indicated by an arrow, and you also see the word Field in red. This indicates that there's one field controlled by this origin marker. Now if we select the origin marker, and right-click, we can adjust some properties. We can move the origin marker. We can also generate the framing for that specific field. We can make a few changes to the framing by accessing the Properties tool. In the Framing Fields property, you can adjust the spacing, and you can change the default framing member. Right now we have a 2x12 lumber. If you want to change it to a different species or grade, you can hit the drop-down. Select the drop-down to select a different lumber grade. We'll just leave everything the same and hit cancel. The origin marker indicates the start location of the joist run. Currently it's starting on the left side of the structure. If we want to move it over to the right side, select the origin marker and select the grip point. and you can move it over to any point along the right side of the structure. I'll select the lower right corner. Disregard the change in the hatch pattern. The hatch pattern is used to represent the floor volume. It does not indicate the direction of the floor joists. You can also modify the joist direction by selecting the marker, click on the grip point, and right-click, and you have several options. You can change it to vertical, horizontal, back to default. You can also select a specific direction. We'll click Select Direction. We'll pick 2 points to obtain the angle that we want. Click 1 point, and let's just pick this point. The origin marker updates to match the angle that was set. Right-click, set it back to vertical. I'll just move it back to the left side. If we were to frame the floor, our joist would run from front to back. But in this exercise, we want to change the joist direction from left to right over in the family area. To do that, we'll select the origin marker, right-click, and we want to add a split. We can add a split by a line or by a polyline. We'll use polyline to create this split. A split line is a tool for creating fields within a floor volume. Fields allow the user to control properties for that specific floor area. We will change the joist to run horizontally in the new field, while the rest of the joist will run vertically in the original field. When adding a split line, the start point must be located on an outside volume edge or corner. The endpoint must also be located on an outside edge or corner. This split will be very simple. We'll start from this corner and run it across horizontally. Zoom in, click the corner of our framing, lock it in horizontal with the U key, run it perpendicular, and click on the edge. Hit V to confirm. Next, we need to select a framing detail for that split line. The current framing detail is a field divided with double header. Vertex will add a 2-ply header at the split. We can change it if we want to do a single header or a triple header. Let's go ahead and just make it a single piece of rim or a single header. Now, if there are parameters that we need to make additional changes to, click on the parameters button. In this case, the single header doesn't have any additional parameters, so we'll just hit OK. Now you see that we have our split line, which is in red, and then 2 offset lines indicating that we have 2 fields. When you zoom out, you'll see the word field in this area and the word field in this area, as well as 2 origin markers. We have the original one that's controlling this area. We have a second one in this area. Once you create a field, there's always an origin marker that's associated with it. To change the joist direction for this area, we'll just select the origin marker, click on the marker. We'll hit one of the arrows, left or right, or you can right-click like I previously had shown you. We'll hit horizontal. And it doesn't matter if the arrow is facing left or right, as long as it's horizontal. Pick that point. We have joist running vertical in this area and horizontal in this area. And this is also a way where you can control the different on-center spacing for different areas. So if we wanted to reduce the spacing or increase the spacing, you can right-click, Properties, and we can adjust the spacing for just this area. I'll leave it as is, and we'll hit Escape. Let's go ahead and generate the framing. Select the area, and go up to the plane structure and select Generate Parts. Now we have our sheathing also included, meaning that we've expanded our floor volume. And you see the joist direction change. These joists are running horizontal, and these are running vertical. Let's go ahead and remove our framing and add our support members next. With the floor selected, go up to Remove, and it removes the framing. We need to add a support member along here to support the joist ends. To add support members and blocking to the floor, we need to work with framing lines. To access the framing lines, with your floor volume selected, go up to Framing, select the More button under the Framing menu, and you'll see Lines for Edit Framing Lines. Click on Lines. Framing lines are shown in red and have an hourglass-shaped symbol. In this case, we have a framing line for the split line that we added. We'll zoom out. We'll add a support member over the family room. To access the framing line tools, right-click, and you'll see several options. We can add a cut line, which can also be used for adding a flush member. There's also add support line for adding support members underneath the floor system. We also have blocking and ladders. Since we want to add a drop beam, we're going to select add support line. To add our support member, we need to select 2 points. We'll zoom in, add the beam centered on the wall. Select the center line. We'll Q off that point, hit U to lock it in horizontal. I want the member to start along the edge of this wall. And hit the U key to lock it in horizontal. And we will run it perpendicular to this edge. Under the framing detail, we need to select the type of drop beam. Click the drop down. We can select a single drop beam all the way up to 5 plies. We'll add a beam that's just a single member. So select the first option, selectable drop beam. Click on parameters so we can select the type of beam that we want to add. Right now it defaults to a 2x10. That's not going to work, so we'll hit select. Let's go ahead and find a glue lam. So we'll go to the glue lam library. And we'll select something that matches our wall width, which would be a 5.5 inch. Let's go with a 5.5 inch by 12. So it's 512 by 12. And select OK. And OK to close out this window. And again, OK. And along with that beam is a framing line. That's why we had 2 staggered one. One controls the header for the framing, and the other one controls the member that we just added. If we want to edit this member, we can just click on that framing line, right-click, and go back into Properties, hit Parameters, and we can change it to a different type of member. Hit Cancel, because that's the size we want. You can zoom out. Now we're still in the Edit Framing Lines, so we want to add a flush member next. We'll right-click, and this is a cut line, because it's going to cut the joists. So we'll add cut line. And we need to add our line, indicating the location of the member, or our cut lines. So we'll find the center line of this wall, hit Q over that point, hit U key, and we'll to reference that point and come over to that edge. And now we'll lock it in horizontal and go all the way to the opposite side. Now our framing detail for our cut line, we've got cut line with blocking. So if there was a bearing wall underneath and all we needed to do was cut the joists and add blocking in between the joists, this would work. But we want to add a flush member, and this time we're going to add a 2-ply flush member. So we'll select cut line with 2 selectable flush members or flush beams. And we'll go to Parameters, Wood Select. Let's just go ahead and add 2 pieces of 2x12. Yeah, we'll just leave it at lumber. Select 2x12. I'll just change it to number 1. Hit OK. And select OK and OK to close this window. And now when we zoom out, you'll see that we have 2 members. And again, a framing line associated with that beam. Let's go ahead and generate our framing. So we can go up to Plane Structure and select Generate Parts. It recreates the framing with the additional framing lines that we added. Escape to clear out the selection. Now we have our drop beam, and we also have our flush beam. If we want to take a look at this in 3D, we can hit the F2 key, and we'll switch it to our framing model. Select the house, That's the only thing we have framed at this time. I'm going to select a single piece of sheathing, Control A to select all of them, and hit H to hide. That way we can see the framing underneath. Zoom in. You can see our joist come to an end on top of the beam, and then our joist turning in this direction. You also notice that we have an opening around our stairwell. So it automatically added double joist along the opening trimmer pieces. And these are the opening header pieces. Now we can control these as well. Maybe we only want single pieces instead of having double pieces. To do that, we need to work with the edge lines. So let's go back to 2D. Zoom out. So we'll do a Shift A to zoom extents. Let's go ahead and hit save. We can edit our framing edges as well as our opening edges. For example, instead of a single piece of rim, maybe you want a double. Same with the side pieces or around an opening. To edit the framing edges, select the floor, go up to the plane structure menu, select framing and edges. You'll see some red triangles pointing to each of the edges. We can click on any one of those red triangles and edit that edge detail. Let's go ahead and select this right edge detail. Click on that red triangle, right click, and let's open up the properties. Now it's using a header detail, but we can override that and change it to a different detail. We select user detail, select header. Under the select detail window, there are different detail options that we can select from. We have furring, opening header, opening trimmer, side, skewed, and obviously header. Let's go ahead and change this to a side double. So we have double the rim for that side piece. We'll select parameters. And there are no parameters to change. It's going to use a default material that's associated with our framing. So we'll just select OK. And you see that it automatically goes through and regenerates the part. And it adds the double pieces of rim there. Let's make a change to the opening header piece. This is a short piece, so let's just make that a single instead of a double. Click on the triangle, right click, properties, select user detail, and it defaults to opening header with double pieces. We want to use a single piece. You also may notice that there's selectable. Selectable allows you to go through, and if you want to change it to an entirely different type of material, let's say you want a piece of LVL, LSL rim, or a glue lam in that location, use the selectable option. In this case, we're going to keep it with the default framing, so we'll keep it at default, and we want a single piece. Select OK. It regenerates the part and applies a single member instead. Get to zoom out, hit escape to cancel that selection. Now back to this rim piece. Over on the right side, you'll notice that we added a double for this side piece. But because of the transition here, it continues through and applies it to the other area. But let's say we don't want a double piece on this area. We just want the double to stop at this point. We need to add an additional point here that tells it to only add the double piece up to this point, and then from there it goes back to a single piece. So we select our floor area. We need to add an additional endpoint, just as similar to what's shown here, but we need to add one at this location. Zoom out. Find that middle grip point, right click, and we want to add a point along this edge. We'll bring it in line with the edge of our rim. Now let's go ahead and generate our part. Now we need to still edit our framing edge. As you can see, now we have an edge symbol for this section. Initially, we only had one single edge that controlled the entire length. By adding the point at the transition, we added a break along the right edge, which in turn added an edge control point. Click on Edge, right-click, Properties. We'll select that header, because it really is a header at the end of the joist when it's perpendicular. It's a header piece, and it's just a single. We'll select OK. So now we have a single piece there, and you'll see that this maintains its double piece. And this is also a header, and this is in actuality a side piece. Hit Escape to clear our selection, and hit Save. Go ahead and zoom out and select Shift-A. There are other objects that we can add to the floor framing using the Lines tool. We use the support line to add the drop beam over the family room, and we use the cut line to add our main support beam in the center of the home. We'll use the Line tool to add blocking and ladders to the floor framing. Select the floor framing, go up to Framing, select Lines, right-click, let's add blocking. After you click on Add Blocking, we need to draw the blocking line. Let's add some midspan blocking along this side of the home. Find the midpoint of this joist. Hit the U key to lock it in horizontal. We'll run it across to the inside of this joist. Now in the Framing Details window, we'll select the Description dropdown, and now we see all our different options that we can select from. We can add default blocking on its edge. We can add 2x10 blocking, 2x4 flat bottom, 2x4 flat top. There are multiple blocking detail options available for selection. We'll go with the blocking default on edge. Under parameters, we can add an offset to stagger the blocking. We'll just hit Cancel and select OK. If we zoom out, our blocking line is represented by a diamond shape, while our split line or support lines are represented by a hourglass shape. If you want to edit the material, you can select the blocking line, right-click, and go into Properties. You can select the drop-down and select a different framing detail. Hit Cancel and Cancel. Now in addition to blocking, we can add ladder framing. If we right-click, we can hit Ladders. The ladder line must be drawn in the joist bay between two parallel joists. The ladder framing is inserted between the two joists. Zoom in on the area with the horizontal joist framing and add our ladder framing in this bay. We'll start along the edge, and it doesn't have to be centered as long as it's inside a bay. Click on the inside edge of this rim, lock it in horizontal, go to the opposite side and select the inside edge of this rim. Now under the framing detail, we can select the drop-down description field. And here are various options for adding our ladder framing. Again, we have ladder default on edge and various other details. We'll stay with the ladder default on edge. Select OK. If I zoom out, we have our ladder framing and the diamond representing the ladder line. Again, you can select the ladder line, right-click, go into Properties, and change your framing detail if you need to. Select Cancel and hit Escape. Select Shift-A to zoom extents. Now that we have our framing laid out, there's some areas where we need to add some connectors. We have joists hanging into a flush member. There are no connectors connecting them, so we'll need to add those, as well as around the stairwell. In addition, we'll also show you how to add some holes. To add connectors, go to the Modeling tab, over to Connection, and select Joint, and then down to Connection Details. Under the joint details, there are numerous categories for different types of joints. We'll focus on the joist hangers at this time. When you click on joist hangers, we have joist hanger beam to beam, joist hanger free. Joist hanger free adds a hanger to the end of the joist, regardless of what the connection is at the end. Joist hanger beam to beam looks at both members, the joist and the supporting member, to find a suitable connector. We'll use joist hanger beam to beam. Double click. We can group select items or we can individually select items. We'll just leave it checked. Go to the lower left corner to see the status line. It says Add Joist Hangers, select Target Piece. The target piece is a piece supporting the hanger. Let's go to the stairwell opening and add some hangers there. We'll add these individually. So we'll add a hanger here, so the supporting member is the header piece at the stairwell. And now it prompts us, select connecting piece ends, confirm. That is the joist that is being supported by the hanger. In this case, it'll be this joist. After you made your selection, you'll see a yellow dot indicating the location of the hanger. Select V to confirm. Under the joist hangers window, we'll see the default library and the default hanger code, as well as other pieces of information. Over to the right, we have 3 filter buttons. Select Best for the best suitable hanger. If you have multiply or wide members, select the bigger filter, or select all to see all the available hangers. We'll start with Best. That opens up our browser window. On the left side, it shows our hanger library, and over to the right are the different hangers that best fit this condition. You can select the column height or the column width to reorganize the list. Select height to organize the list by height. Now we know we have a 2x12 floor system. Let's use a face mount hanger that will work for a 2x12 joist. Let's select the IUT 211. It has a height of 11¼ inches and a width just slightly over 1.5 inches. Double click and select OK. Next, you will be prompted to delete old connecting parts. Every member-to-member connection in Vertex is considered to have a connecting part, regardless if there is a connector or not. Select Delete to remove the existing connecting part. It is being replaced with a new hanger connection. Now if we zoom in, you can see the hanger has been added. We're still in the command, so let's go ahead and add the remaining hangers in this area. Select the header piece, and then select the next adjacent joist. V to confirm. Vertex remembers the last hanger, so we'll just hit OK. And delete. And we'll add the side hangers. So we need to select the vertical piece and the header piece. V to confirm. OK. And the same thing on the opposite side. Select the vertical piece, the header piece, and OK. Delete to confirm. While we're still in the hanger command, we'll zoom out. We can add multiple hangers at one time. Let's add the hangers for these joists in this area. This member is a 2-ply member. We can only add hangers to one side. We need to select 1 ply as the supporting member and then the joists on that particular side. So we'll select this ply. Next, we can select a crossing window and make sure that the ends of these joists are inside the window. So we'll left click and drag till we get this little box. We want to make sure that the ends of the joists are inside that box. Release the left mouse button, and we get the yellow dots for each connection. V to confirm. Select OK. And delete. Let's do the same on the opposite side. Select the ply on that side, and then crossing window around these joist ends. V to confirm. OK. And delete. Let's add hangers for the other joists. We will come back to the double joists and add hangers for those. So let's zoom out. We'll select that piece and see if we can get all of these from this point over to this end. V to confirm, and delete. Now the ply on the bottom side. Again, ignore the double joists. We'll come back to those. Crossing window, select the ends of those joists. V to confirm, delete. Let's zoom in. Both of these are double 2x12s, so we can add the hangers for both of these at the same time. So select this ply. Try and grab both ends using a crossing window. You can also pick each joist end individually. Confirm both ends are in the selection window. When we zoom in, you might have a third dot. That's because there is an additional horizontal piece overlapping the flesh member, and the end of that piece was also selected by the crossing window. Click on the yellow dot to unselect it. And we can unselect, let's see, that one. So we should only have those dots. We'll come back and delete that piece out later. So hit V to confirm. Now you notice there isn't a hanger code or a hanger available. For wider beams, we need to select hangers from the bigger category. And click on the hanger library. And let's organize this by width. So we have 3.5 inch wide member. And we need a hanger for a 2x12. Let's keep it as a face mount, so we'll select an IU-T412. The height is 11.25, and the width is just over 3.5. Double click and select OK and delete. Now we have a hanger to support our 2-ply member. Hit escape to cancel the command. While we're here, let's delete that piece of extra material. Click on that piece and delete. You can also add holes to the joists. Go back up to Modeling, Connection and Joint, Connection Details. Scroll down till you find Service Holes. Over to the right, you can see we can add circular holes, oblong holes, rectangular holes to the joists, and various other holes. Let's go ahead and add a circular hole. We'll double click. We can select the diameter. Select the drop down. Let's leave it at, let's go 3 inches, that's fine. You can set the depth. Since this is a 1/2 inch material, 2 inches is fine. It can go a little deeper, make sure that it cuts through the material. We can select a position. Is it near the top of the joist, the middle of the joist, or the bottom? And you can also add an offset. Let's just leave it in the middle. And we can also add multiple holes by selecting the quantity. Let's go ahead and add 3 holes at 12 inches apart. We'll select OK. We'll zoom out. Let's go back to this area back here. Make sure we're selecting our floor area. V to confirm. The status line in the lower left corner is prompting us to select a point. Since we have a quantity of 3 holes at 12 inches apart, the line that we're drawing is the middle hole, and with holes offset at 12 inches on each side. I want to start at this point. Select the I key to lock it into vertical. Go all the way through this joist. The 3 holes are represented by the dashed line. So we have holes in the joist going along each one of these lines. Let's switch over to 3D to view the hangers and the holes. So hit the F2 key. Switch to framing modeling. Select sheathing. Control A and H to hide the sheathing. We zoom in, you can see the holes. We zoom back out. You can see the hangers that have been added to this flesh member and also around the stairwell. We've completed our framing for this floor, but I do want to cover how we can add additional materials or profiles to this floor. To add profiles, select your floor. Under the Plane Structure Framing menu, we have Add Profile. There are several options for adding a profile. We can add a profile or joist in any direction. We can also copy an existing profile or joist. We can add a primary beam. Or we can add a profile that's linked to any plane on this structure. Let's go to the top of the menu and select Add Profile. Under the cross-section area, we can select the cross-section and select any one of these types of profiles. Under the Code drop-down, we can select the size or profile. Under Classifying Data, we can select the use, if it's a joist or a beam, and its function, if it's a header, side member, opening member, blocking ladder. We'll just leave it as a default as joist. You can also set the location of the profile, if it's flush to the top, flush to the bottom, or dropped. We'll leave it at flush top. Now, if we want to add a profile that matches a member that's already existing in our framing, we can select the Pick button at the lower left corner. Select the framing member. I'll select an existing joist. Now our cross section is updated to match those properties. Let's go ahead and select OK. And I'm just going to draw a member in between these joists. Here's our new profile. Let's add another profile. This time we'll select the second option from the menu, Add Profile. Use this option to copy an existing floor joist. Select Add Profile. It's prompting us to select a point. Let's add a joist in between these two. Now you notice that it didn't prompt us for a piece or a type. It inserts a joist that matches our default framing. Next, we need to select our length. Do we want it to extend just to the field or through the area? If piece line length is set to field, then the joist only extends to the nearest split line and flush member. If through area is set, the joists ignore the flush members and extend through the entire area. We'll leave it at field and select OK. Next, under the framing detail, we can change the type of detail. We'll leave it at joist. Select OK. There are no parameters available for this detail. If we want to mirror this joist, we can check the mirror box. Leave it checked to have it permanent or part of the framing. And select OK. And it adds a joist to our framing. There's another profile that we can add. There's a primary beam. The difference between the primary beam and the other two options, the primary beam is not connected to the floor framing. So if you were to regenerate the floor framing, your primary beam is not affected if the floor is regenerated. Select Add Primary Beam. Again, you can go to the cross section, select the library. And I'll just select a different size. It doesn't really matter. We can set the use, and we can also set the function. We can select the location, flush top, flush bottom, or dropped. I'm going to set this one to dropped. Now select OK. I'm just going to draw the beam from right to left. Again, this isn't part of our framing, just for training purposes, so it doesn't really matter where I place this. The primary beam is indicated by the red dashed lines. There's also another tool for adding profiles. The fourth option down, Add Profile, allows you to add a profile to any plane in this structure or project. So if we select Add Profile, again, similar options. Let's match our floor joist. So I'll select pick and pick one of the joists. And I'll select OK. When adding the profile, you can select the locating point. You can select from the 9 locating points in the dialog. The locating points are used for adjusting the profile when adding it to the model. Start from the left side. Lock it in horizontal direction with the U key, and then select the inside edge of the rim. Hit Escape to cancel the command. Let's take a look at these objects in 3D. So hit the F2 key. Switch to the framing view. And let's hide the sheathing again. This time I'll use the modeling tab to hide our sheathing. Go down to the lower left corner, model tab. We're working with the first floor. Come down to sheathing, right click and select hide. You can see the additional profiles. And you'll notice this profile is not in plane with our floor framing. This profile was added using the profile tool that applies a profile to any structure plane. It may not line up exactly as you intended. To adjust the location of this profile, select the profile, right-click, and select Edit Heights. The 3D level for this profile is set to First Floor. First Floor is the top of our floor framing, which also includes our sheathing. We have an offset value of 0, and the reference point of the joist is set to center, explaining why the middle of the joist is in line with our top of our floor. Change the center to top and select OK. You can see the profile has shifted down further into the floor framing, but it is still extending above the floor framing. The reason for this is that it's actually at the very top of our floor framing, which again includes our floor sheathing. So we'll need to select our joist, right-click, and select Edit Heights. And we need to add an offset to account for the floor sheathing. So we'll add a negative 3/4 inch for our 3/4 inch floor sheathing. So now it will line up with the top of our floor framing, minus the 3/4 inch for the sheathing, and that's the top of the joist. Select OK. Now you see that it is in line with our top of our floor framing. Using the fourth option under Add Profile can require more work when aligning the profile to the floor plane. This option can apply a profile to any plane in the structure, which requires more adjustments in order to line up the profile to the plane. Hit the F2 key to go back to 2D. Any of these profiles or framing members can be modified. If you select a member, you get a middle grip point and 2 endpoints. Select the endpoint. You can extend or shorten the length of a profile. Click that point, and yes, we want to remove the present joints. You can select the middle grip point to move the profile. I'll lock it in vertical and just shift it up a few inches. You can change the profile properties by double-clicking on the member. Maybe we want to change this cross-section to something different. You can modify any piece in the framing just by double-clicking. One thing to be aware of if you made manual edits to your floor framing, when you select Generate Parts, your framing will go back to its default state. Once you start making manual edits to your floor framing, it's best to avoid using Generate Parts. Since we've made some of these changes manually, so if I select a floor, select Generate Parts, Vertex refreshes our framing back to its default state. And you see the changes that we recently made are no longer there. If I zoom out, you'll see that some of the joists that we added are also gone, except for the main support beam and the joist that was copied using the Add Profile second option. Profiles added using the first and fourth option are removed anytime you generate framing. If you use the second and third option, those will not be affected by regenerating your framing. Now that the floor framing has been completed, The next step is to add a material schedule and labels to the materials. Since we are working with an unpacked floor, let's add labels to our floor sheets. Go to the Output tab. Next to Profiles, there's Sheet Schedule. Click on Sheet Schedule. In the Sheet Schedule parameters, we can add labels, a material schedule, and drawings. You can also remove these existing items if you have previously labeled your sheets. Select Remove for each one of these items. In this case, we're adding them. So let's make sure we have Add. Under Labels, we have New Location or Current Location. Leave it set to New Location. Vertex will add the labels in the default location. This is typically the center of the sheet. You have the system. The system is the label style. In this case, we have S as a prefix, followed by a number for the sheet. For schedule, we'll have it Add a Schedule. If you want to include drawings for any special cut sheets, check the Drawings box. Set it to ignore any full sheets or rectangular sheets. And if you have previously created sheets, it will delete the old sheets if this is checked. Select OK. Now you will see that the labels have been added to the center of the sheets, and the schedule is now linked to your cursor. Select a point to add the schedule. Now if we zoom in on the schedule, you'll see the label, the quantity, the material of the sheet, description, basically it's the size of the sheet, and the area. So if we zoom out, you can see that each sheet has a label assigned to it. We also check the drawing box for Vertex to create any drawings for sheets with irregular cuts. Go over to the Project Document Browser on the left side, expand Structural Sheets, Sheet Drawings, and you see that it created 3 drawings. One for S4, S5, and S8. Let's go ahead and open S4. And here's the cut sheet. The drawing shows how this sheet needs to be cut. We'll close out. Go to sheet 5. Similar type of cut, just on the opposite direction. And then sheet 8. And sheet 8 has a couple of additional cuts. If we zoom in on the drawing, we can locate where those sheets are. So there's sheet 8. If you click on it, you can see the shape or the outline of the sheet. And the others are around the stairwell. So we have sheet 5 and sheet 4. Again, it only creates drawings for sheets with irregular cuts. Anything that's rectangular or full sheets will not have drawings. To remove the schedule and labels, go back to Output. Again, select Sheet Schedule. Select Remove for each of these items. We'll keep the sheet labels and schedule, so select Cancel. Shift-A to zoom extents. Next, let's add labels to our joists, hangers, and beams. So again, we'll go up to Output tab. This time under Profiles, we'll select Schedule. In the Select dialog, you have different materials that you can create schedules for. We have floor joists with group labels. The difference between these two options, floor joists will label each individual joist. Floor joist group labels will create a group label for similar length joists. And there are also various other materials that we can create schedules for. Let's go ahead and select floor joist group labels. Next, we get a piece schedule parameters similar to the sheet parameters. Again, you can add or remove labels, the schedule, and drawings. We'll leave the label location set to base. We'll have it check overlapping labels. And we'll just have it check all the labels and refresh them all. System is the labeling system it's using. We'll leave it at the default. Presentation is the label macro or the label style. Under schedule, we have macro. Macro is the schedule style or layout assigned to the material schedule. The format is the material that it's creating the schedule for. In this case, we have floor joists. And the presentation is the label that's being applied to the joist itself. So it's using a piece.schedule label. For drawings, we won't have it add drawings for each individual joist. If you do want it to have drawings for any specialty cut joists, you can have it create drawings for any joists that do not have perpendicular cuts or notches. We'll leave this unchecked. We'll select OK. Similar to adding a sheet schedule, we have a schedule linked to our cursor. Select a point to add the sheet to the drawing. Now if we zoom in on the schedule, you'll see that it says floor joist schedule, our piece ID, quantity, the material, the application description. We got blocking, beam, header, joists, ladder blocking, the length, and any angle cuts on each end. Zoom back out and let's look at the drawing. If we zoom over to this area, we have our blocking pieces all labeled. You can move the label by clicking on the label, click on the grip point, lock it in a vertical, and you can move that down to add some separation between the blocking line and the label itself. Let's add a hanger schedule. Again, we'll go up to Output, Schedule, and let's go down to Joist Hangers. We'll create the labels, add the schedule, and select OK. Add the schedule to the drawing. We zoom in. Here's our joist hanger schedule. We have H1 and H2, and the different hangers, the IUT211, the IUT412, and the description of the hanger. We zoom in on the hangers, you can see that each one has been labeled. Here's our H1s. In the stairwell, you'll see our H2s for our double joists. We are working with an unpacked floor, that's why we see the sheeting on our floor. Under plane structure, there's the option to expand or pack the floor. Now, if it was packed, then we would not see the sheets or our floor sheeting. Now, in this case, we have both our floor framing and our sheeting. Now, if we wanted to make a drawing for each one of these, when we get to the point of actually creating a PDF or a drawing, we could assign a layering style or a layer group. We can use this level to create two separate drawings, basically by controlling the layer group. Just to give you an example, go over to the floating toolbar. Mine's over on the right side, yours may be on top. And I'm going to select layers from list. Now when we get to the point where we're actually going to plot a drawing or create our sheets, all we need to do is change our group for this sheet. So if we scroll down and go to Plot Floor Frame, click on the light bulb. By selecting the Plot Floor Frame, you'll see that our drawing has changed and only layers that pertain to floor framing are visible. This includes our schedule and our labels. Now if we go back to the Layer Group window and select Plot Floor Sheeting, now only objects that pertain to the sheeting layout are visible. It turns off the labels for the joists and schedules for the joist, but it retains the sheet schedule and joist hanger. By using plot groups, you can create different drawings from one layout. Let's go back to the floating toolbar and select Restore Default Layers. Now that we completed the framing for the first floor, we're going to move up to the second floor and add the framing. But instead of framing the entire floor, we'll actually panelize the floor. Go up to the Open Drawing Model Pair, and in the Drawing Model Pairs window, select Second Level Deck Layout. Now let's turn off the walls for the upper floor and show the walls for the lower floor so we can see where we have support. So we'll go into Reference Drawings and Properties. We'll uncheck the second walls and turn on first wall layout so we can see the lower level walls. If you do not have a reference drawing for first level walls, go up to Reference Drawings, Quick Load Model Pair, and select first level wall layout to add a reference drawing. Just hit escape. So again, I'll go back to reference drawing, properties, and select first level wall layout. And uncheck second walls. And select OK. Now we have our first level walls shown and our second level walls hidden. But this gives us an indication of where we have support. So we have a bearing wall right in the middle, and we'll need to add a beam at the back to support the ends of these panels. Let's take a look at the framing tool for this floor. So we'll select the floor, go up to framing tools, and it shows we have 2x12 floor framing assigned to this floor. It's using the tool library from the floor structures. And we have an on-center spacing of 16 inches on center, which is fine. And our materials for our joist, side, and header. We'll leave this all as is. Change your spacing to 16 inches on center and leave everything else as is. And select OK. We will add a drop support beam over the family room. Select the floor. Under the plane structure, or under framing, select the More button. Select lines. Right-click. Let's add a support line. We'll add a drop beam to support the panels. Zoom in. I'll select the center line, hit Q, select that point, lock it in the horizontal. We want it to go in line with the face of the framing or the edge of this exterior wall. So we'll click that point, hit the U key to lock it in horizontal again, and all the way over to this corner. Under the framing detail, we'll select the drop down and we'll make this a single selectable drop beam. Select the parameters button. Let's change this to a steel member. So we'll select steel library. So we'll scroll till we find steel. And let's go ahead and select W8 by 18. And select OK. And that's 5¼ inches wide, so it should be close to matching our wall width. So we'll select OK. And OK again. Now that we have our support beam, we need to add our panel or panel breaks. With the floor selected, we should have the panel structure menu and go over to panel breaks. I'll select Shift A to zoom out. We can panelize the floor and create panel sections that can be built in a shop or on a job site. With panel break active, you'll see that the cursor has a line with some rectangles indicating the direction of the joists or framing. Right-click to bring up some tools for generating panel breaks. We can add a single panel break to our floor area. We can add multiple panel breaks to an area. We can add a panel break to a field. So once we actually add a panel and create a field, and we can add multiple panel breaks within a field. We have the spacing or the width of our panel, quantity, and seam width if we want to add a little gap between each panel. We have a seam detail number 1, seam detail number 2, parameter set, and we have the full cut, picked cut toggle. When the toggle is switched off, the panel break lines are trimmed to the edges of the area closest to your pick point. With the toggle switched on, the panel break lines will extend through the entire area. Select Add Panel Breaks to an area to add multiple panel breaks. Next, select Spacing. Since our floor is 40 feet in width, we'll break this down into 4 sections. We'll make each panel 10 feet wide. So we'll change that to 120 inches. Select OK. Right-click again. Change the quantity to 4 for 4 panels. Select Seam Width. Let's add a gap between the panels. Set the gap to 1/4 inch. Enter 0.25. Select OK. Select the lower left corner of the wall framing. The panel breaks will offset 10 feet to the right from this point. Now if we zoom out, you can see that we have 3 red lines for 4 panels, each 10 feet apart, minus the seam width. With the floor selected, under Plane Structure, under Panel, select Generate Panels. Right mouse click and confirm the panels are built based on the current layers. This should be the default setting. Select OK. Each panel that we have generated has its own field, so we have 4 fields here, 1 in each panel. To generate the floor panels, select a single field to only generate the selected panel, or group select the fields to generate all the panels. Do a crossing around all 4. Each one is now green, indicating it's been selected. We'll hit V to confirm. In the panel build dialog, we have numbering, structure, and use. Numbering is the ID, how the panels will be identified. 2F indicates second floor, and 1 is the sequence or number of the panel. Under the structure drop-down menu, you have options for ceiling panel, rake panel, roof panel. Working on the floor panel, we'll leave it as is. Over to the right, we have parameters. Under the framing properties window, we'll want it to generate our framing, so we'll have that checked. And in which direction do we want our framing? Shortest span, longest span, use defaults. And we also have generate sheathing. We'll leave these checked, but I want to change the span to the longest span. So I want the joist running all the way from the front to back. Select OK. The use field indicates the panel type. We're working on floor panels, so we will leave it as is. If you uncheck Remove Panel Breaks, you'll be able to go back to your panel breaks and edit them. We'll change that to uncheck, Remove Panel Breaks. Select OK. Vertex BD then generates your panels. We zoom in. You can see that we have our 1/4 inch gap between each of the panels. And each panel has an ID. An asterisk indicates that a drawing has not been created for this panel. We can add hangers, blocking, ladder blocking, the same way as we did on the main floor. Select your floor. Go to the Modeling tab. Select Joint. Connection Details. We'll go to Joist Hangers. Select Joist Hanger Beam to Beam. Select OK for Group Selected Items. Select the supporting member, which will be this piece, and then the joists that are being supported. V to confirm. We'll select Best. Now organize by height, and select the IUT 211, which is 11 1/4 inches in height. And select OK. And delete old connecting part. And now we've added our hangers. We'll add hangers at the end of our 2-ply member. Go to Joint, Connection Details, select our joist hanger, OK for Group Selected. Select our supporting piece. We'll select the 2 joists supported by the hanger. V to confirm. Then we'll select bigger. We need a bigger hanger. Under hangers, click on the library. Organize by height. And we'll select the IUT 412. It's 11 1/4 inches in height and 3.5 inches in width. And select OK. Select Delete. And we'll do the same thing on the other side. Zoom to the other end and add the hangers on this header. Now we'll support the double pieces. Select bigger, hanger library, and the IUT 412. And the exact same thing on the other side. Now let's add some blocking to our panels. Since we have 4 individual panels, we'll need to add blocking in each panel. Let's start on the right side. We'll select our panel area or field. Only the floor area for that panel is highlighted. We'll go up to Panel, select the More dropdown, and select Lines. Right-click, and we're going to add blockings. Zoom in to find an intersection point. Hit S to find an intersection. Select U, lock in the horizontal, and we'll run it perpendicular to the inside edge of the rim. Under the description dropdown, we'll select our first option, blocking default on edge. That'll use our default framing material for blocking. Select OK. Under parameters, we can add an offset. I'll just leave the blocking in line. Cancel and select OK. Right-click and hit Exit. We'll need to do the same thing for the other panels. We'll select the next panel. Under Framing, select the drop-down, Lines. This time the blocking line will go from this edge to our double member, and the double member to the inside edge of the joist. Right-click, Add Blockings. I'll find the intersection by moving my cursor over the intersection that I want. Press the S key to select the intersection, U key to lock it in horizontal. Select the edge of the double member. Select OK to use the last settings. Right-click, Add Blocking. Now this time we'll find this edge of our double member. Select S, lock in the horizontal with the U key. Select that intersection and OK. And now we'll select this panel. Again, go up to Panel Drawing, drop down, and select Lines. Right-click, Blockings. Find the center line of the wall and intersection with the joist on this inside edge, and select S. The U key, run it all the way across, perpendicular to the inside edge. You can see there's our center line of our seam. So you want to go to the inside edge of this joist, or the last joist of that panel. OK. V to confirm, and we've got one more, this last panel. I should mention, when selecting the floor panel, it is best to select the panel label. I've been selecting the floor hatch pattern, which also works, but at times it might select the entire floor area, not the floor panel. Either select the panel label, or continue selecting the hatch pattern until only the floor panel is highlighted. Go up to Panel, expand the More button, and select Lines. Right-click and Add Blocking. Find the inside edge of this joist. Lock it horizontal and to the inside edge of that joist, and select OK. Now we've added our blocking for each panel. Hit escape to cancel out of the command. Shift A to zoom extents. Now let's create our panel drawings. So we'll go to Output. Under Panels and Trusses, select Panel Drawings. Over on the left-hand side, under Element Drawings, it lists all our panels. You'll see the ID and the drawing status. So our drawings are out of date or not created. So you can create each individual panel drawing by selecting a panel drawing, right-click, and create, or we can highlight each one of them. Select the first one, keep your finger on the Shift key, and select the last one to highlight all 4 of them. Right-click, and let's hit Create. Under Panel Drawing Templates, under Floors, we'll select our floor panel drawing since that's the only one we have, and we'll select OK. Now we can go through and open each of our panel drawings. So if you want to open a panel drawing, we'll go to, let's say, 24F5, open. There's our panel drawing with our blocking. You can also open a panel drawing by going to the ID. Once you select the ID, up on top of the menu, you should see Open Drawing. Click on Open Drawing and it'll open that specific drawing. You can expand it. You can see our blocking, our hangers, see our piece list, our label, quantity, material, description, and the length. You can see there's our connector schedule as well. You can zoom in if you need to move some labels around. You can do that by just clicking on a label, selecting the grip point, and you can clean up any overlaps. Go ahead and hit Save to save that drawing if you make any changes, and hit the red X to close out. Select Shift A to zoom all. You can also access the panel drawings from the Project Document Browser. Go over to Structural Drawings, expand that list. Under Floor Panels, you'll see each of the IDs. You can double click and open the panel drawing from there. Select the X to close out. We can add a panel schedule to the drawing. So if we go up to Output, under Panel and Trusses, select Schedule. From the Select Panel schedule, you can create schedules for different types of panels. We're working with floor panels, so we'll select Floor Panels. And we'll add that to the drawing. If we zoom in, we have our floor panel schedule, our label, quantity, the code, which is the material, the width, the height, and the weight of each panel. Unlike the main floor framing, where we added material schedules and hangers on the drawing, the material schedules are part of the panel drawings. We can print individual panel drawings. We select the label, right-click, and select Open Panel Drawing, or you can select it from the top ribbon. With the drawing open, we can go to File, Print, and the Print Drawing dialog, we'll select PDF. This was an 8.5 by 11, so we'll change the sheet size to ANSI A 8.5 by 11. We'll set the scale to fit the sheet, and we'll change this to a 90-degree rotation. Select the middle box to center it, and we'll select OK. Under the Save As, set the save location. Now it won't automatically open the PDF, so you'll need to use your file browser and search for it. Use your PDF viewer to view the drawing. You can also create a PDF book of the panel drawings. Close this window. Go over to File, Export, to Edit PDF Sets. We scroll down, you'll see a Panels Floors PDF book. We'll use that to create a PDF set. Hit Cancel. Go to File, Export, Print PDF Sets. Select Panels Floors and select OK. Enter a file name. We'll leave it at the default name. Vertex collects the panel drawings and creates a PDF book of the drawings. After Vertex assembles the PDF booklet, it opens in your default PDF viewer. And we have a booklet with each of our panel drawings. Close out. Let's view our floor in 3D. So we'll hit the F2 key. We'll switch to our framing model. You can see that our upper floor has been panelized. There's seams at each of the panels. Let's go ahead and turn off the sheathing. Let's go over to the Model tab on the left. Go to Second Floor, Panels, Floor Panel. And now this is a 24F. On this panel, we can select sheathing, right-click, and hide. You'll see that it only hides the sheathing for that specific panel. If we select a piece of sheathing, do Control-A, again, we can select all the sheathing and select H to hide. We can rotate. See, there's our hangers. There's our panels with our seam. And there's our drop beam. Switch it back to the architectural model and select the F2 key to go back to 2D. Shift-A to zoom extents. And save your models. Go to File, Save Project. That concludes our floor framing training. In the next video, we will cover wall framing.